So, as we discussed the topic of semantic role labeling, one more aspect to be considered is that in semantic role labeling, uh, the systems they treat each argument as argument of a predicate as independent from each other when they are classifying the arguments. Actually, this assumption of independence, because we know that in a sentence, in a language, the arguments are not independent of each other, but they are dependent on each other and they provide much information, something like location, the time, the number. This information will be given by the arguments. So we cannot assume totally that it is completely independent. So because of this assumption, there are two important disadvantages. One is when we assume that they are independent of each other, sometimes they will be classified as same argument. That means the constituents will be overlapping. There will be overlapping assignment. And this overlapping is not allowed in the resources, whether it is prop bank or framenet. Two arguments of a verb predicate cannot overlap or cannot have the same classification. Something like both cannot be assigned argument 1, both cannot be assigned argument 2, like that. Secondly, because we are ignoring the dependencies among the arguments, we may be facing the risk of losing information between the arguments because we are completely ignoring the relationship. So we may lose the information, something like if the subject and object they follow certain sequences, something like time, location. So they will be dependent on each other, and this dependency we are ignoring. So how we can overcome the independence assumption? Firstly, we can put a restriction that we will not be allowing overlapping of the arguments classification. So you know that we are using SVM, and SVM will predict the probability of labeling a particular argument as argument 1 or argument 2. So when we take the output from SVM, highest classification confidence, highest probability will that label will be assigned and all other labels will be labeled as null. So only one will be taken so that there will not be any overlap. For example, if you take a sentence but nobody knows at what level the futures and stocks will open today. When generally when it is being classified, predicate is knows, and one what level is classified as argument 1, and the futures and stocks will also be classified as argument 1. So this is overlapping problem, and this is not allowed in the prop bank. So how we are dealing with this? We are when the SVM assigns labels by the confidence, where there is more probability that we will take, and all others will be labeled as null. So there is no question of assigning argument 1 to different constituents. The second method to overcome, the first method is disallowing the overlaps. The second method to overcome independence assumption disadvantage is argument sequence information. This is more principled approach involving retaining the argument ordering information and treating the predicate also as a part of sequence. So what we do in this method is we take trigram model, a 3-word combination model, and it is trained on argument sequences. And you know the Viterbi algorithm from the earlier, there we can select the most probable sequence, and we will be calculating the maximum likelihood path, and we will assign each node a value from the prop bank arguments. So this search is made with a constraint that no two non-null nodes overlap. This method is particularly effective for core arguments but less effective for adjunctive arguments. Hope you remember what are core arguments. Argument 1 to argument 0 to argument 5, then adjunctive arguments, temporal, location, these things. So what we do in this method is we train a trigram language model on the argument sequences, and using Viterbi best parse will find the maximum likelihood path. What is the likelihood path from for each node? Then third technique to overcome the independence assumption is post-processing. If you remember, we also seen yesterday in the previous class that post-processing is used in classification paradigm. So what is post-processing stage? It will remove implausible, which are not possible argument classification. That we will remove, and we can incorporate argument specific language models to refine the prediction. In the previous classification paradigms, we have seen post-processing filtering all the nodes also, null nodes also. And the fourth approach is using approaches that attempt to jointly decoding, not independently decoding, but jointly decoding all the arguments instead of treating them independently. So this will involve the modeling the independence between the arguments through techniques such as conditional random fields or structural prediction models.